In the last video I introduced quadratic equations and showed you how to solve them. In this video I want to continue on with some more examples. This example here is the quadratic equation x squared minus 6x plus 9 equals 0. A, the coefficient of x squared is 1. B, the coefficient of x is minus 6. C, the constant term is plus 9. We plug all those numbers into this formula here, so we get minus 6 or plus 6 plus or minus the square root of b squared, that's minus 6 squared is plus 36. Minus 4 times a, which is 1, times c, which is 9, and the whole lot is divided by 2 times a, where a is 1. Now, normally what you do then is just go to your calculator and plug in b squared minus 4ac. And if you do that, you will get 0. You'll get 36 minus 36, which is 0. So the next stage then normally would be to get the square root. We get the square root of 0, which is 0. And we usually have two solutions. We have 6 plus this number over 2, or 6 minus whatever this number is over 2. But here, because the number is 0, you see it doesn't matter whether we take 6 plus 0 over 2 or 6 minus 0 over 2. We only get one solution. So there's only one solution to this quadratic equation. Sometimes this one solution or root is known as a repeated root. You will see that if you factorize this expression. So let's look at the factors of x squared minus 6x plus 9. Well, what are the factors of plus 9? Well, in order to get minus 6 in the middle, the factors of plus 9 that we must use are minus 3 times minus 3. They'll give us plus 9. And if you can check for the middle term, you get minus 3x from the outer terms and then minus 3x from the inner terms. Putting that together, we get minus 3x, which is minus 6x. So now we have the product of these two factors equals 0. The next step is to put each factor in turn equal to 0. So if we put this first factor equal to 0, we get x equals 3. If we put the second factor equal to 0, we get another x equals 3. So that's why this root of 3 is sometimes referred to as a repeated root, because we have two equal factors, or two repeated factors. Here is the graph of this quadratic function. As I explained in a previous video, the graph of a quadratic function is a parabola, and it's an upright parabola if the coefficient of x squared is positive, which it is. The coefficient of x squared is plus 1. A is equal to plus 1. And the graph crosses the x-axis at the roots. Now there's only one root, so the graph must cross the x-axis at 3. So that means that the graph must just touch the x-axis at x equals 3. By the way, the graph will be symmetrical about x equals 3. In other words, the value of the function at x equals 4 will be equal to the value of this function at x equals 2. Solve 3x squared plus 2x equals 0. Notice that in this example there is no constant term. C is equal to 0. Now the easiest way to solve a quadratic equation where c is equal to 0 is to factorize x out of both of these terms. So if we do that, we get x times 3x will give us back to 3x squared, x times 2 gives us back to 2x. So it's very easy to factorize a quadratic equation without that constant term where c is 0. And from the product of these factors giving us 0, we know what to do. We put each factor in turn equal to 0. So this is one of the factors. It's just a single term for this quadratic equation. It's just x. So we can see that x equals 0. That gives us one of the solutions straight away. So if we plug 0 in for x, you'll see that we do indeed get 0. To get the other solution, we put this factor equal to 0. And we get x equals minus 2 over 3, or minus 2/3. So if we were to draw a graph of y equals 3x squared plus 2x, we'd see that it would cross the x-axis at minus 2/3 and at plus 0, and at 0. Now we could also have solved this equation by using our formula. A, the coefficient of x squared is 3. B, the coefficient of x is 2. C, the constant term, is actually 0. You could even put in a 0 here if you like. plus 0 just to write it out in the correct form, and then plug these numbers in to your quadratic equation formula, and we get out our two solutions. But you can see it's much easier and quicker to factorize it. You just pull x out of these two terms. Finally, I want to look at a quadratic equation that has no solutions. I want to see what happens. Now, we write down what a, b, and c are. A, the coefficient of x squared is 1, b is 1, and the constant term is 2. So our solutions are minus b, that's minus 1, plus or minus the square root of b squared, that's 1 squared, minus 4 times a is 1, times c is 2. And all of this is divided by 2 times a, or 2 times 1. So we get minus 1 plus or minus the square root of 1 squared is 1. So we have plus 1 minus 8. Plus 1 minus 8 is minus 7 divided by 2. You can see the problem. We have a negative number here. We cannot get the square root of a negative number. So we say that this equation has no solutions. You will see in the section on complex numbers how to deal with such equations. So all of quadratic equations with no solutions lead to the idea of complex numbers. So that's another section, that's a different section. I just want to look at a graph of this. If the x squared term is positive, that means it's going to be an upright parabola, and it will not cross the x-axis. So it's going to be looking like that. Now I don't know exactly where it is, but I do know that it's going to be an upright U-shape that lies above the x-axis. So there's no solutions. So this is the graph of y equals x squared plus x plus 2. In the next video I will look at some past exam questions.